So we have two examples here where we're finding inverses. We're going to go through the steps again, and but they're not linear this time. They're not linear functions. Okay, so here comes our first example. You can see it's a cubic function, right? All right, first take out the notation f of x, put in the y. All right, now we switch the x and y. Now we have to solve for y. Well, how are we going to do that? We're going to subtract the 1. And then how do you get rid of the cube on that y? Because you want y to be by itself, right? So you're going to have to take the cubed root, put little 3's in there, of both sides. And so what we get is the cubed root of x minus 1 equals y. And you can write that the other way, y equals the cubed root of x minus 1. So then the notation is going to look like f inverse of x equals the cubed root of x minus 1. And you could verify that by composing them, okay? And it'll work. Cubed root is fine. That's not going to cause any problems. It was lovely. It was a little bit different, because with the cubed root, but that's how it works. We know how to solve those kind of equations. Okay, our next example, this is a rational function. So you can see the rational expression in there. And notice there's a restriction over here that says x does not equal 3. Well, you can't have in the function, you can't have x be 3 because then you'd be divided by 0. And so 3 is not part of the domain. Now, in this particular example, we're not going to go into the restrictions so much, but later on in other examples we will. So here we're just going to find the inverse. Okay, so we write y equals x plus 2 over x minus 3. Okay, we're going to switch the x and y. X equals y plus 2 over y minus 3. Notice that now we have two variables of y in there, like y is in two places, right? Okay, so that hasn't happened before, but it's happened here. So how do we solve for y? Well, the first thing we're going to do is multiply by the LCD, which is y minus 3. Or you could use a proportion if you wanted to. Okay, distribute on this side. So you're going to get xy minus 3x. And then on the other side, you're just going to have y plus 2. But remember, the goal now is to solve for y. We're on step 3, and we want to get y by itself. So here's how we do it. Any term that has a y in it, get that on the left. So bring this one over. And any term that doesn't have a y, get that on the right. So you're going to have xy minus y. It's going to become minus y. And then over on the other side, you're going to have 3x plus 2. Okay? So it's going to become a positive 3x when it switches to the other side. All right. That was a little tricky. You might want to rewind the video and watch that part again. But we want y terms on the left, terms that don't have y on the right. Okay. The reason for that is because now we can factor out a y on the left-hand side. And what are we trying to do? We're trying to get y by itself. So divide by x minus 1 on both sides. So we get y equals 3x plus 2 over x minus 1. Or we got to do step 4, put the inverse notation in. It says the inverse of f inverse of x is 3x plus 2 over x minus 1. Now, you could try to say, oh, I think this is always going to work like this, and try to jump to some conclusions, but it's best to just work out the math, the algebra here, to get the right answer. Okay, and you might be thinking, well, can x be 1? And we're not going to go there right now, but later on we'll talk about those restrictions.